Okay, let's go ahead and look at the right triangles and trigonometric functions. So let's label the triangle. So say we have theta. So this right here is going to be theta. If we follow theta across, this is going to be the opposite side. And then if we look at our right triangle, our right angle of the triangle, and we follow that across, we're going to get our hypotenuse. And then what is left over is going to be the adjacent. So this is the adjacent. This is the opposite. And this long side will be our hypotenuse. Always remember that you're going to be using the Pythagorean theorem. So you're going to be using a squared plus b squared equals c squared. One thing that I do want you to know about this triangle, so it's A, B, C. So you're going to say I have A, B, and C as the vertices. And then you have A, little B, and little c as sides. Okay, so definition of the 6 trigonometric functions. When we're talking about the triangle that we have to the left, we're going to say that we're going to let theta be an angle or be an acute angle of a right triangle. So if theta is the acute angle of a right triangle, so we have our right triangle and we have theta, you're going to say that there are 6 trig functions of the angle theta that are defined as the following. Okay, so you have sine, cosine, tangent, cosecant, secant, cotangent. So these are our 6. It's 1, 2, 3, 4, 5, and 6. So what's important about these trig functions are they're basically ratios of the sides of a triangle. So the trig functions are ratios of the sides of a triangle. So the triangle that we're talking about is going to be ABC. So you're going to say that your triangle is ABC. So as we're talking about sine, let's go ahead and define them. So as we're defining them, you're basically going to say that sine, which is S-I-N of theta, is going to be the opposite side over the hypotenuse. Cosine is going to be cosine of theta. You always have to have the angle theta, which is going to be equal to adjacent over hypotenuse. And then the tangent of theta will be equal to opposite over adjacent. So with all that in mind, we now have on the right-hand side angles 4, 5, and 6, the reciprocals. So you need to know that this is the reciprocal function So this is the reciprocal function of sine. And it's going to be cosecant of theta is equivalent to the reciprocal, which is hypotenuse over opposite. Secant is going to be the reciprocal function of cosine, which makes it secant theta is equivalent to hypotenuse over adjacent. And then finally we have cotangent, which is the reciprocal function of tangent. So cotangent of theta would be adjacent over opposite. So these two are reciprocals. So if you recall, a reciprocal, let's just write it down right here. Is a flipped fraction. So all you're going to do, since you see opposite over hypotenuse, you're going to flip and you're going to have hypotenuse over opposite. And you're going to see that for each one. So you're not really having to define much. Okay, so let's look at example 1. In example 1, we're given the sides 8 and 15. And it says the instructions say, find the exact values of the 6 trigonometric functions of theta. Okay, so if you're having trouble memorizing the sides, you're going to remember this. So, toa, or SOHCAHTOA. It's basically saying that this is going to be a sine, so it's opposite over hypotenuse, cosine, adjacent over hypotenuse, tangent, opposite over adjacent. And then you know all of these right in here are reciprocals. So all of these are reciprocals. So let's look at what we have here. In example 1, we have 2 sides, and we're missing this third side. We know it's a right triangle, so I can say that this side is the hypotenuse. I can say that this side, so this is theta, we're going to follow it across, and this is going to be the opposite. 15 is the opposite. And then 8 would be the adjacent. So what I'm looking for is the hypotenuse. We can also say that you have A equals 8, B equals 15, and C equals we're not sure. So we're going to say A squared plus B squared equals C squared 8 squared plus 15 squared equals c squared. 64 plus 225 equals c squared. 289 equals c squared. You're going to take the square root of both sides because all I want is c. 289 c squared, c equals 17. So I now know that c equals 17. Okay, so let's go ahead and fill out our trigonomic identities. So sine is opposite over hypotenuse. Our answer is going to be 15 over 17. Cosine is going to be adjacent over hypotenuse. So 8 over 17. And then tangent is going to be opposite over adjacent. So opposite over adjacent is 15 over 8. Okay, and then we know everything over here is a reciprocal. So the reciprocal is going to be hypotenuse over opposite. So if I say hypotenuse over opposite, 17 over 15, which is 17 over 15. Secant is going to be hypotenuse over adjacent. So hypotenuse over adjacent is going to be 17 over 8. And then tangent or cotangent is going to be adjacent over opposite. So 8 over 15. Let's look at example 2. Okay. Find the exact values of the 6 trigonomic functions of theta if sine of theta is equivalent to 3/5. So what I know is that sine is going to be opposite over hypotenuse. So let's label our triangle. So you're saying that opposite is 3 and hypotenuse is 5. So whatever is across from the right triangle or the right angle is going to be the hypotenuse. This is 5. And then theta, you're going to say is going to be opposite. So this will be theta. And this over here will be opposite, and this will be 3. So we need our Pythagorean theorem because we don't know this side. So I'm not sure what A is. Remember, this was opposite, and this was hypotenuse, and A is for adjacent. So we're not sure what adjacent is. So, in other words, I can say that when we're going over here, there's a reason why I did this. 3 is going to be B, and 5 is going to be C, and we're missing A. So A, we don't know. B equals 3. And C equals 5. So when we substitute, we can say a squared plus 3 squared equals 5 squared. A squared plus 9 equals 25. You're going to subtract 9 from both sides. A squared equals 16. So a squared equals 16. I just want a. So we're going to take the square root of both sides and say a equals 4. So a equals 4. So now we can go ahead and set up our ratios. So sine of theta, we already know is 3 over 5. Cosine of theta is going to be 5 over 4, so it's adjacent over hypotenuse. 5 over 4. Tangent is going to be opposite over adjacent, so it's 3 over 4. And then we know that these are reciprocals. So I'm going to say 5/3. Again, the reciprocal. 4/3. And the reciprocal. Oops, not. This is 4/5. 4/5. And then the reciprocal of here is going to be 4/3. Okay. All right, see you in class.